Good morning, folks. Hope everything's going well with all of you. So as far as I'm concerned, I thought I'd reduce the glare for a bit. This hat came courtesy of Mr. Tilly at the last staff golf tournament. And got distressing news. I'm down to my last 2 ginger biscuits. But Mrs. G says I'm going to be allowed to go to Tesco's tomorrow. So exciting times. Anyway, talking of exciting times, we are going to be doing some differentiation with functions with 2 or more terms I see today, so let's move on. Right, so we're differentiating functions with 2 or more terms. So the question might come in the form, find dy dx given that y is equal to 4x cubed plus 2x, and we just need to remember the same rules as we were doing yesterday. So dy over dx is going to equal, we multiply by the power, 3 times 4 gives us 12, drop the power by 1, so it's x squared. Then when you've just got x on its own, because that would go to x to the power 0 and that would be 1, it'll just be 1 times the 2. So we just drop the x and we've got 12x squared plus 2. So there's the first one. The next one, write that down. You might want to have a little go at it. Before I do that, I'll have a little bit more of my biscuit just to give you a moment to do that. You might want to pause the video. So we should have dy over dx is, well, 3 times, lose 1 on the power, again multiply by the power 2x just to the power 1, so that's 2x. Now when we've got a fractional one, we still multiply by the power, so it's minus a half, and then if you take one whole number away from a half, you've got negative a half. And you could rewrite that so that it's 1 minus 1 over 2 the square root of x, but you don't need to. You can just leave it in that form. So the next part, we get, the next example is y equals 1/3 x to the power half plus 4x squared. And for this, we'll start off doing the same idea. When I multiply 1/3 by a half, I'm going to get 1/6, so that gives me 1/6. My power becomes negative a half, and on the other one, 2 times 4 is 8, and then we've got our 8x, and we can leave it in that form. That's all we need to do. The same question might come in this form. Now here they haven't given you y equals or function of x equals. They've just said differentiate and given you an expression, in which case you'll need to do the same thing. So if we look at the first one, a, you could say let, and you could either go for y or the function of x. So if we say let y equal 1 over 4 root x, then before you differentiate it, you want to make sure you get your terms involving x as a multiplied term just with a power. So I could then say that that's going to be the same as 1/4 x to the minus a half, because the square root is a half, and because you're dividing by it, that becomes a negative. Once I've got that, I can differentiate that the usual way. So I'm going to need to multiply 1/4 by negative a half. Well, if I multiply positive by a negative, I get a negative. Half times 1/4 is an eighth, and my power is going to drop 1, so from minus 1 over 2 will become minus 3 over 2, because 2 halves make a whole. Looking at the next one, you don't have to say let y equals 2, so we'll do it the other way this time. So we could say let the function of x equal x cubed 3x plus 1. But we don't want brackets, so we need to multiply all of those out so that we get two separate terms involving x. So 3x times x cubed is 3x to the power 4, and 1 times x cubed is x cubed. So that's going to be my function of x, and when I differentiate that, 4 times 3 gives me 12, the power drops to 3. X cubed will be 3x, power drops to 2, so 3x squared. And that's that one done. Now, you may want to factorise your answer at the end, but you don't need to. And the last one we're going to have for today, if we stay with what we've just done there, let the function of x equal x take 2 over x squared. Now this one's a little more problematic, just to get into, because we've got an x function up here and we've got an x term up there and one below there. We need to split it into different terms. So remembering what happens when you're adding or taking fractions, we can split the numerator if we keep the denominator the same. So that will give us that, but then we need to think about what does that mean in terms of powers of x. So x divided by x squared would be 1 over x, which is x to the power -1, and 2 over x squared, we've got the negative in there, and then it would be 2x to the power, and you just turn the power negative like that. So this is our function, so we don't get confused. I'm going to write that again. X to the -1 minus 2x minus 2. And therefore, when we differentiate, we're going to look at the power times by -1 will just give us minus x to the power of, the power goes down 1, so -1 take 1 will be -2. -2 times -2 is +4, so that'll give us 4x to the power of -3. And you can mess around with it and put it back into fractions to put it all in the same sort of form that the original question was in. And if you look at the example in the book, they've done that there on page 267. But I don't want you to worry about that, because if it asks you to differentiate, if it hasn't asked you what form to leave it in, you don't need to do more than that. So let's keep it reasonably simple. Right, so all we've got to talk about now is what questions I want you to do. So page 267, exercise 12E, and we start off with doing question 1, and then question 3, parts A and B. If you can do those without any trouble, don't worry about the other two on there, but if you do want a bit more practice, you can do those. So that's question 3. Question 4 has got a whole load of them in it, but it's a really good idea to practice through so you're feeling solid on it. And then once you've done that, we'll just skip on to the exam and problem solving questions, question 6 and question 7. Now I am expecting some of you to want to ask for some help on some of this, because it does get a little tricky. I'd be more than happy to share my work solutions with you or answer any questions you have. Okay, good luck with that, maths friends, and see you again tomorrow.